got everybody here that's going to turn up if they didn't run away from the last meeting. Try to start. Obviously I'm somewhat nervous, I'm not used to doing this, so please bear with me, and if I start speaking too fast, please yell at me to slow down. I'm Andy. This is Neil. Neil's been working with Lava now for
2 years.
2 years, and started to talk to me about a hardware solution for a problem he's been seeing. That's what we're trying to talk about this morning. So, testing units is relatively simple with one unit. You have, most target boards will have some sort of serial connection, terminal, console, probably Ethernet, certainly need power. Testing one unit's not really an issue. However, once you start testing several systems, we start having a little bit more fun. Your cabling becomes a bit of a mess, and you could be running around for a while trying to find out which unit you're dealing with. And that's not too bad. You know, we can cope with 2 or 3 units, but for automated test, you start having a few issues. I might need to reset the unit. I might need to pull the power, restart it. Which unit has come up on USB 1 when the kernel's been reloaded, and I know it's enumerated differently, so your ports have moved over the place, so which one is which unit? So this is Neil's desk in Cambridge.
One of the tidy units.
Yeah, I'm told these are all. Actually, Neil tells me all of these are tidy desks.
Hey.
So these are the ones we're allowed to show. Apparently, the untidy desks we can't show.
I resemble that statement.
You'll recognise that desk.
Yeah. And at this point, we're starting to see, in order to provide automated testing, you need some sort of power distribution, something you can turn on and off power from individual units. You need a serial terminal server, because, well, you may, if you're lucky, have a serial port on your PC. These days, it's usually hanging off USB somewhere. But if you've got half a dozen units to test, a rack full of them, a lab full of them, you rapidly end up relying on serial over Ethernet and some sort of packet switch. So it can be a bit of an issue. It certainly becomes a bigger issue by the time you end up putting everything into a rack. That's better than tidy, actually. I guess.
Is this a get a Dave?
No, this is nice. I mean,
Well, thank you very much.
This is generally nice. I mean, everything's on nice standoffs. You've colour coded everything, so you know which cable is which. Obviously, the blue cable is Ethernet. Oh no, that's not the red cable.
Yeah, blue is Ethernet, red is serial.
Yeah.
Red is
Which is great. So, which one's unit 3?
Sorry?
On the patch panel, which one's unit 3? Yep. At 3 o'clock in the morning, when somebody's come in and gone, oh God, I've just got to get it to work, and just slammed a unit into the first available slot, it can become a bit of a pain in the neck.
If they don't document it, they get shot.
See, document control by assassination works.
Yeah.
Of
I'm
course,
a fair dictator.
you end up with also an awful lot of test kit or support kits just to have your rack of units. And then there's the power bricks. We mentioned that there needs to be a power distribution unit, something you can turn power on and off, but test units typically are small target boards. They might have a power brick. That's not too bad. PDUs come typically with an IEC power connector on them. That's okay. But what if your power brick is an integrated wall-warped power supply? You're certainly not going to be able to plug that into your PDU, so you end up with a power socket on a lead, then a power brick hanging off the power socket. So you've probably taken 3U of shelf space just to put the power supplies.
And that's one per device. If you've got 20 devices in the rack, you've got 20 power bricks or 20 leads hanging off.
So from that gave us a bit of a design brief of what we tried to solve. So we need to solve power distribution. Target boards at the time were all 5 volts. Most of them can be powered over USB. Not too bad if you can power them over USB with a reasonable power supply behind them. If you can't power over USB, maybe you take a USB to 2.1mm, 2.3mm barrel jack. Units typically have a serial port. Everything needs a console somewhere. That may be RS-232 if you're lucky. If you're not so lucky, it will be straight off the UART with no buffer, and please don't get it wired the wrong way around, please stop trying. Hopefully that's going to be 3 compatible, but it might be 1.8, it might be 1.1, it might be 0.8, but we're going to stick at just at the 3.3 volt, and you need a packet switch. And to try and make this a little bit easier, Neil envisaged 2 solutions. A simple desktop solution for your home labs, for your workbench, able to support 3 or 4 units. Integrate something like a QB truck as a dispatcher for lava if you're running lava on the system. So you end up with one box containing everything. And then perhaps add a daughter board, put it inside a 19-inch rack case, and you can support a few more devices. In this case, we're suggesting 8. So it turns out that when you start putting everything into one box, the telecoms guys use the word convergence. You suddenly gain some extra features. And one of those features is, first of all, you only need one power socket for your power supply. But by switching individual power supplies, you can gain some more subtle power management. So we ended up with putting on a small Coulomb counter, something to measure our energy, not just measuring whether there's a voltage present, but how much power is flowing through, integrating both voltage and current measurements at the same time. And it turns out that gives us effectively a software definable fuse. So if you're doing board bring up, for example, you can specify this board, this EUT shall not exceed 2 amps. And the second it exceeds 2 amps, the platform pulls the plug on you. So your EUT is potentially protected. It can then raise an alarm and interrupt back, so your dispatcher or whatever can recognise that you've got a problem. Or you may choose to just flag the event and continue. That definable fuse is definable down to tens of microamps. But we can also measure power being consumed by each EUT. Okay, it's not great. I'm not instrumenting each individual line of the PMIC on my EUT. I'm just looking at what the PMIC's got. But if you want to do some power basic power optimization, we could rerun multiple tests with code running in different ways and actually determine, do I get away with this with an overall lower power consumption?
If I use so much power, if I actually start cross-building GTC or Clang or something, do we actually have a bigger power draw on the board? How much bigger does that get? Does it rise over time? Do you get problems with it actually starting to keep on pulling more and more power the more you use it?
How do you get the power data?
It's so on that we have a host micro, which is providing our serial terminal services. It's providing a USB terminal server. It's nothing fantastic. It's a little Beagle Black, but the power monitoring Coulomb counters are all on the I2C bus up there.
But it's all logged, right?
Yeah. So it will all be logged with missing software, software.
And also, what's the kind of sampling rate? Like, how often can you see what the last time slice of?
Okay, so the Coulomb counter is integrating in less than a millisecond. I think it's, got to remember off the top of my head, I think it's 200 microsecond sample rate by default. So it's not absolutely fantastic, but it's good enough to give you a reasonable setup. It's also configurable to give you a pulse count of overcurrent before it triggers. So you can set it up to be instantaneous, so you peak over once, or to allow multiple time cycles before it gives you a signal, so it'll allow short transients. Also turns out, as we're doing this, we end up with, we've said we're going to need USB as our power supply, or effectively we can now also give you USB host as well as your serial console. It's just another channel on the USB. Then we added an additional USB hub into the design, but it didn't really add much in the line of cost. And finally, all of the connections, we chose to go for air gap isolation, so we're just using relays. Not really great on USB. It does break the USB spec because we're out of our control impedance over the relay. But it does mean that our power, serial and USB connections are all isolated when we choose to disconnect the unit. And that's kind of useful on some of the boards we've played with, because I know the pull-up resistors on the UART may be enough to latch up your target board because they're so low power. And if you're looking at early day boards where maybe the power domains on the control on your target board aren't quite right, you need to disconnect the unit.
This is one of the things that Tyler referred to in the kernel CI talk. Automation is hard because of exactly these kinds of problems. You think, well, I'm just going to yank the power off this keyboard too, and then put the power back in, and you watch the serial console, and a different bootloader comes up. Instead of Sun 7i, you've got Sun Xi. Sun Xi has about 5% of the functionality of the proper bootloader, doesn't see any of the actual external media, it only sees the NAND flash, and you can't get back into a working environment.
So
and you have to power cycle it again, and sometimes you get it. But actually what you have to do is you have to kill the power to the serial. Even though the red power cable is not connected to the board at all, you've only got ground to RX and TX, it's putting enough power over the RX line that it latches the first stage bootloader.
Well,
It's a hardware design issue, but it's the kind of thing we see a lot.
and it's the 3.3 volts on the TTL. It's enough to power the SoC, so it doesn't go into reset.
Yeah.
So
Yeah.
we're actually not resetting the board.
Exactly.
Yay for low power.
Yeah, low power's great. And of course, so we also have an option on the board to discharge your power rails through a suitably high power resistor. I looked at doing this with a simple transistor, a simple gate, but again we're looking with some fairly low power SoCs. Is my nominal 0.7 volt drop across my transistor going to be still not enough that I've still left the thing in latcher? If we're dealing with 0.8 volt logic, actually, yeah, we're screwed. So it does need to be air gap, it does need to be a relay. Can I add yet another relay onto the board? I've got a lot of relays on this board. Can I add yet another relay so we can choose to actively discharge? Actually, I've run out of space. We could probably find a nice small relay to do this. So if you do want to actively discharge your power rail, there's a jumper to set for each EUT that you want on the system. You can just leave the unit for a period of time, let all the internal capacitors discharge. You may still have to leave the unit for a period of time because the unit I've designed doesn't have diode protection on the front of it, maybe some sort of FET protection, so you're not discharging power back up power line, which means all my capacitors are not going to actively discharge from a short on the upside power rail. So you may still have to wait time. You may still have to stick a 10K resistor across the input. So what do we end up with? A fairly large board.
A bit larger than you hope.
Yeah, it's a minor cock up on the on the mechanics. Not a huge cock up. It's supposed to be to fit in a 19-inch rack. Whoops.
This is the biggest beagle bone cape ever
It is the biggest beagle bone cape ever built. Yeah, it works perfectly okay on a 24-inch rack.
It'll fit on top of the rack perfectly well.
So essentially what we've got here is, I'll be around that, nice and simple. We've got space for 4 EUTs. Each one has a serial port or a simple UART connection and a switch to decide which one you're going to use. Again, we could have made space and put the switch and just left it on the same connection. Fairly guarantee somebody will switch in the wrong state and will stick -9 volts of TTL input. No, not worth it. Power, as we said, is via a USB output, and again we can use that as USB host back to the unit. And we have an Ethernet connection on for the unit. So we've provided power out, we've provided a serial console, a USB console as well, it just happens to be there, and we've got Ethernet on the unit. We're not doing anything with the Ethernet, we're putting an Ethernet packet switch inside the box. But it does mean that you only end up with occupying 1 U of space or 1 box on your desk to do everything. And this is repeated 4 times. Space for a daughter board, which is a cut and paste.
And do you have relay on Ethernet as well?
So there is no relay on Ethernet because the Ethernet by default is isolated. It's inductively coupled, it's magnetically coupled, it is not DC
but there
coupled.
is standard to provide power through Ethernet here.
This is not a PoE device, I'm just passing Ethernet through. So if you have to use, if you're using PoE, you're going to end up with replacing the packet switch inside the unit. Maybe you're going to run an external PoE system. PoE, you can tell it to turn power off your switch anyway, so I'm going to expect you to have an Ethernet connection to the switch, so there's already the mechanism there to turn off individual power channels. There's a daughter board that sits over the top of here, which, as I say, is just a cut and paste of what's on.
The advantage this gives you is that for each of the channels, you've got all your connections together. You've got Ethernet, the USB, for the power, and your serial, all lined up together in a line. Then the next block, then the next block, then the next block. And because you can this is only a half depth unit, you can see we have a shelf very close by and very short cables. You know exactly which cables go into which channel.
Cable tie them all together.
Yeah.
So you end up with a cable bundle.
Yeah.
The intention is to have all the connections on the front. It is only a shallow depth, so there's no reason why you can't have back-to-back units. So instead of 8 units in 1 U, you can effectively have 2 of these, giving you 16 UTs of 1 U of host. There's a series of empty sockets here. They are populated, I just didn't have a 3D model. There's 3.5mm headphone jacks. I'm using them to provide GPIO. That allows us to potentially press a reset switch, press a power switch. How many EUTs have you had on? I'm looking at the IMX 53s here, where version 1s, you power them up, and they sit there and do nothing until you hit power. Great if you're on automated testing. Somebody has to run into the machine room, hit the power switch, walk out again. So yes, you're probably going to have to modify your EUTs to put a switch across, a cable across the switch, and that just plugs in.
Some devices, looking at nobody in particular, might actually have the paperclip solution. This avoids that problem because you just solder something either side of whatever you're trying to circuit, and now you've got it as a controllable switch.
Except that's a 12-volt board.
The limitations here, this is a pull to ground. So if you are on a 12-volt board, most of the switches typically are pull to ground. You'll have to check. IO on here is 12-volt tolerant, i.e. I can pull it to ground and I don't care if you give me 12 volts. It's not going to blow anything up, but I can't output. So it's active low only, I'm afraid. But I can, you can also read that signal, so although it's only a logic input, so I'm not giving you an analog input on here, but if you need to see that you've got 12 volt present, you can use one of those lines for that. You only have 8 lines of GPIO brought out to the front. So we've not committed them as one per EUT. It's 8, do as you will. Some EUTs may need a power and a reset. Other EUTs might not need anything. We have power coming in from the outside world. We've selected a couple of power supplies off the shelf. It's capable of handling a 50 amp power supply. As it is, we've got a 25 amp power supply available to us. Across 4 units, that's possibly overkill. Across 8 units, yeah, maybe we might need that for powering everything at once, especially if you've got spinning discs. There's a series of connectors back here for fans. I'm expecting this to go in a 1U box. Packet switches are also going to share the same enclosure. Yeah, we might need some fans. They are the standard 4-pin PWM controllable fans. So we've got various, we've got thermistor on here and various point takeoffs for thermal measurement. It's crude, it's rough, it's only an A to D on the beagle bone. Don't expect wonders of it, but it's certainly enough that you can do internal case measurement and report back if, for example, we're overheating. EUTs probably are as well.
It does mean you can spin down the fans, so that when it's powered up, you would have the fans come on, and then the bigger one would just power them down.
Yeah, so idle your fans will shut them down if you don't need them. And finally, we've got some power outputs, again, switched off the beagle bone, aimed at power supply for your packet switchers, and also for your dispatcher if you've got one built into the box. We've left enough real estate in the mechanical box to place something like a QB truck on a chassis and run that inside the unit with its hard disk if you want to have an integrated dispatcher in here as well. If you don't need the dispatcher, fine, we don't need to include it in the box. And on the front we've just got a simple reset switch, power and status LED, and our uplink Ethernet. Whereabouts are we as far as the project is concerned? Clearly, we've got PCB and schematic complete. We do have boards back. I'm about 85% of the way through populating the first 2 boards. I think I might have bitten off more than I could chew. I'm trying to hand solder this. Actually, 0402s by hand is not a problem. 0.5mm pitch. ICs genuinely aren't a problem. The USB hubs and the USB to serial are on 0.5mm pitch QFNs with a ground plane. So I had to borrow some specialist kit for that. But we've got the chips down now. I think I'll get the first 2 boards assembled, do the smoke test, do initial board bring up, make sure nothing dies hideously wrong, and I'll pass out to a subcontractor to get the rest of the boards built, put a stencil together,
Yep.
and get somebody else to build them on a machine, because to be honest, you need a binocular scope and I haven't got them.
What does the 8 unit version look like?
Exactly the same.
Okay.
There's this section here is literally cut and paste. So effectively, chop that off. That sits as a daughter board. So we've got mounting holes in position, and we've got a an FFC connector. Literally pulls up. You've got 2 spare channels on the uplink USB hubs, so it's literally copy and paste circuit.
Okay.
So on board bring up, I only need to confirm this, and then I can just confirm by strapping across my connections that it works on the other two ports. Now that's probably quite a good thing to stop at this point and say serial ports. We've placed down on here they're simple FTDI serial chips. They all have internal flash, so we can define them and give them serial numbers. I would suggest giving them serial numbers associated with the GUT port. 1, 2, 3, 4,
That's
5, 6.
crazy.
I'm sorry, due to the idiosyncrasies of the CAD package, I can't start at 0. It won't let me step and repeat from 0, so I have to step and repeat from 1. So it's an American number system.
Okay, sorry.
You deserve that one.
Oh, at least it's get a time now.
Share alike. Likewise, the USB hubs, I've provisioned for a bit of serially squared flash on them, but I don't believe I need it. The devices in question allow you to port swap and pin swap the data lines. I've not needed to do it on the board layout. However, we may find it's an advantage to, again, serialize these things so they always come up in the, so they're always enumerated. Well, no, sorry, so we don't care how they're enumerated. We can identify them as UARTs 1.
Why do you decide to do it monolithic board? I'd expect kind of stackable daughter cards.
Doing it as this gives us a 1U rack enclosure.
It's keeping up.
So it's a bit wider than it should be. So it should be about this sort of size. But it means we can fit it all in a 1U rack. If we stack boards, then we're going to end up with an awful lot of PCBs interlinked. Connectors are the bane of your life. They are unreliable. FFC connectors, really, you can only insert 10, 20 times before you need to change them. USB is controlled impedance. If you go out through a connector and back again, you're now looking at quite exotic connectors to maintain that impedance, which is not the same impedance as the I2C and control line should be. So you end up with multiple connections for stackable boards. No.
Yeah, I understand.
What you can do with these is you can have this one with the daughter board and you just chain them through networking. So you can have multiple units of these, 1U each, and they all just work over the Ethernet. So you can have multiples and they all behave as distinct units.
So sticking with where we're on board bring up, I know my power supply is good, I've tested that already. Haven't done any of the other board bring up. We're currently defining what the software should do, but the intention is to provide 2 simple control systems for it. One is a simple web interface. Click on a button, it proves that the I/O works. You can turn your power on and off. So a simple web interface. And then for automation, provide a sockets interface, which Neil is going to be writing for us.
Simple telnet, tell it to do something. It tells you whether it did it or not.
It is fully open. The software will be made available. Neil intends to package it for Debian and hopefully, well, we clearly missed Jesse.
Yes.
But the intent is to have this available in Stretch.
Yeah.
The CAD is available now. It's on the server. we're not just providing Gerber files and schematics as a PDF. We provide it in native formats. In this case, I did all the CAD in Altium. So there are raw CAD files. It's clearly the Gerber files. There's clearly the ODB plus manufacturing files. If your PCB vendor likes that. But we've also provided the raw CAD. We've also provided the pick and place files, the library files, the 3D models. So yes, fully open hardware. Now the real bit. Help!
This is where you come in.
We're probably going to need a little bit more software support once we've got basic board bring up. I was hoping to have the boards in a operational state before coming to you today. I don't, I'm not there. I missed that goal, I apologise. In the next few weeks we will certainly have one or two boards in a, you can telnet into it and start playing with hardware. This is the question, can we have some contributors, people who'd like to work on some of the software for this? Really appreciate some help.
What about the availability of getting the boards once they're in a better state?
We can order more, that's not a problem. I've personally paid for 10 boards and I've got all the hardware to build 10. Make that 9 because this one's a write-off. I wouldn't like to populate this board because it's been through quite a few heat cycles when I was working out how to put down the QFNs. It's too big. I need to refactor this. So I'm expecting, unlike software where you can just hit recompile and retest it, I'm expecting to have to do some wire mods on here and spin a PCB. At that point, we know it should work because we've tested the prototypes, we've got a working system. At that point I'd like to make it available. I'll get them commercially manufactured. We've got the CAD for the enclosures. We'll get somebody to cut, to CNC cut the front panel. It's supposed to be designed to go in a particular box cycle. Slight measurement error, my apologies. So we will be able to populate these and have them built up. I'm expecting them to come in circa £500 a board, assembled in a box with your packet switch, with your power supplies.
When you think how much a reliable serial console server costs, and then the cost of the PDU, this is coming in at the cost of the PDU without even thinking about what the console server costs.
I've got a question about that because I've had terrible reliability problems with the USB serial.
Yes.
And more so when I've tried to do it on a BeagleBone Black. So
there are changes that have gone in with that. You're using Rev B BeagleBone Blacks. There is a known issue with those, and we are speccing Rev C only of the BeagleBone Blacks for this. You're also not using the absolute latest mainline or BeagleBone kernel on that BeagleBone Black. You're also using commercial USB hubs. So there are other failure points within that, but yes, it is something that we are
all taken
Yeah.
completely into account.
Yeah.
I'm moving away from serial to USB in the lab because even on x86 servers we have problems because of USB in general.
Yes.
Right.
So from a production lab perspective, I'm moving away from USB serial because I really can't trust it.
I'm
going back to Avocet. I'm going back to Avocet site limits.
Right.
So dedicated UARTs.
Yeah.
Okay.
Question about the Debian image that's going to run on the BeagleBone Black.
Yeah.
Are you guys planning to produce that image with all the DTS lit overlay and
No,
software?
we're planning on using the stock.
Okay, so
Debian,
everything will just
BeagleBone,
be-
and apt-get installed OpenTAC.
Okay, and then you're going to do like a DTS fragment to add all the bits for the dice.
Yes.
Okay.
So just DTS overlays.
Okay.
It's yeah.
And all the
I've done a
source
couple
code
of
for that.
overlays before
Yeah.
for the black. Yeah, it's changed. Really, I should have put an I2C header on here to describe it, but even the black, even the stuff from the circuit code they've taken that away. Nobody's using them anymore. It's a real shame. It was the right thing to do. But no, DTOs are now just purely divided into software, and away you go. You just say it's there.
Yeah.
So that be packaged as part of the OpenTAC package rather than
Doing custom image.
custom image.
So I was going to say, when you receive a board like this, all the source code, everything you could need will actually be installed on the big one black, because you've got a nice bit of flash on there. It was a storage space. It doesn't make any odds. You might just have everything on every copy you get. Just have it there, and you can fiddle with it and play with it. It'll also be in public Git locations as well, and all the links will be, all the documentation, everything will actually be pre-installed, sitting there on the board.
So the Rev C ship with Jesse now. Are you guys just thinking you're gonna take a Rev C, stick it on there,
Rev
and
C.
send it up?
Unless
on
we
that.
find any problems, I'm expecting to go with the Debian mainline kernel. If we need to go to the Regal bone kernel, then we'll.
Okay.
Yeah.
Does the £500 per box figure, is that for 4 boards or 8 boards?
Right. That's we think we can build it at that price. It's not about making profit. It's about getting open hardware out there, and it's about getting you guys with some test software. To be honest, this is a fun project. I'm really enjoying doing it. Not so much with the soldering. I have to confess. I've forgotten just how long it takes. Give you an idea, I'm currently 300 and something hours into this project. I'm getting a tack time of 44 connections an hour. That's not bad for hand soldering. But there's 2,600 connections per board. Yeah, now you can see why I'm saying I'm bitten off more than I can chew. It really is going to take too long to do by hand. I thought I could do just prototypes. Now that was a mistake. We'll probably look at some of the UK subbies to produce this, mainly because I'm just round the corner.
You already have the pick and place stuff figured out.
Or the pick and place I did with the cat. I mean, that's fine. That's all in. What I didn't do is order a solder mask. They're relatively cheap to order. It cost about 80 quid for a solder mask from a good sort of Sparker or something. And then just get a subby to build these. They're not panelised boards. They're lineage finished boards. So yeah, this is stuff that they could just paste and hand place. I suspect that's probably what they'll do for the next 7. When we go to revision B boards or revision 2 boards, I would expect them to put them on a pick and place.
The other thing worth mentioning here is we are thinking of other variants of this 12 volt, different serial configurations if those are necessary for a particular implementation. If you've got ideas, if you've got requirements that these things actually need to do particular things, particular setups, then we can build that into a future version of the board. The initial design was for developers on their desks, and we were thinking it's going to be useful in probably labs of Tyler's size, and then we're hoping they get them into the Cambridge lab as well. But if things have changed and things need to move on, there are other variants we can plan and put in once we've got the initial design up there.
Well, particularly since the some of the server platforms, dev platforms, which are coming out now, require 19 volts.
Yeah.
You know, so it's
These were designed.
Requirements creep.
Yeah.
It's always going to happen. Actually, to be honest, this is quite a useful project anyway. We learn an awful lot from this.
I'm not criticising the project.
Which means there could be a future spin.
Yeah, so my intent here is not to criticise the project. I think it's a great idea. I've always thought that lava in a box, as we used to call it, was a great idea. But for a production environment, I've now to be convinced a lot more of reliability of things like USB serial, because I have been playing with USB serial for a long time.
Yeah. So coming back to the USB serial, let's have a few niceties on here. If we break the connection to our host, we don't drop the USB serial.
No, it's usually kernel issues.
Yeah.
It's not the hardware.
No. But also
this is
there's a few other issues anyway with that, so I thought I'd just mention it. We can physically break a connection to the host by the relay.
Yeah.
We don't have to break every single relay on the EUT. We could just break the serial. We can independently reset each FTDI chip where needed. Again, I know it's not necessarily solving
I don't
your
think
issue.
the problem is
Yeah.
it's systemic, as Neil said. There's a series of things involved in all of this.
Has this been reported to the kernel developers, the issue that we're seeing?
I'm only really
probably
now starting to realise
This is
how
it.
bad it is.
Yeah.
Okay.
That's why I'm making this decision to go to Avocent and go back to using the CycleD's serial console server.
But
Because
with things like this actually available to kernel developers actually on their desks, things like that can actually be investigated. We are a software company. If there's a software problem in the kernel,
we need to get that reported and make sure
Yeah.
that people are aware of it.
Yeah, no,
but the kernel
completely agree.
developers also need a way of reproducing the kind of faults you're seeing, so I'm actually getting hardware out to them that can.
Yeah.
If we stick the USB serial issue to the side, can I just have a show of hands? Are we doing the right thing? Is this something you guys
Yes.
want?
Yeah,
I
absolutely.
want one ASAP.
Thank you.
Any volunteers for helping some software? Cool.
Thank you. Little bit.
Any other questions?
Does it run Fedora?
Someone wants to port it, that's fine. It's all software.
So,
Yeah.
sorry, I came a little bit late, but so the main idea is you have a Regal Gone Black that will give you like the web, like HTTP server and socket interface, and then sending commands to the Regal Gone Black, you're gonna control the serial port, the power, and the USB power.
USB
of
data,
2A
yeah.
ports.
Yeah.
To boards, and also monitor what power usage is, and effectively provide a software definable fuse.
Yeah, I mean, also to play a little bit of devil's advocate right here. So the only feature that I see that is not really commercially available is the measuring power
Oh, indeed.
part. Well, but I mean,
The advantage with this is that
It's
you,
all in
you
one
lose
box.
you lose all those power bricks, because all the PDUs you'll find are 240-volt AC, and you've got to step down from that every single board. 20 boards are in a rack.
like, because right now we use a box that is Ethernet controlled.
Yeah.
It's a web server. It costs around $80, and it gives you 8 relay ports, and that's what we use to switch the boards in our farm. And then you can put, in case of USB, you know, we put an extra relay in the USB power cable, because the relays have the normally open, normally closed contact. So with one relay we can do both at the same time. And the only thing that we don't get is we don't get the serial interface, but for that we use a commercial USB to serial.
Indeed. That is a perfectly valid solution.
Maybe show your first couple slides, because I think
Yeah.
that framed the
Yeah,
problem.
probably I came late, so.
Yeah, I think it's just,
Okay.
it's like the organizational problems, like I have 100 boards in my lab, and I've got cables all over the place, and it's a complete mess, and it's like frightening to go and try to do any maintenance on the board, because you never know what you're gonna knock off, so this is, I think, the problem, trying to organize it down into one single.
And you have to hack your serial cable every time you want to add a new board, right?
Yeah.
If you're putting a relay in line.
Or USB cable, yeah.
Or
Not, oh yeah, but not all the boards, like, not all of the boards get power on USB. Only very few. So yeah, on those ones we have.
So that's actually becoming more of a problem I'm seeing. So like the Android type phone development boards that are out there have this problem. And so as we start to test more of those, that becomes an issue.
Usually I'm developing board on a separate file.
Yeah, that's true, but I have about 16 that
Yeah,
don't act
yeah.
like
Besides
that.
USB power for the boards, I mean, I didn't catch it. You have some like DC barrel jack.
No, we've got, if you're not using the USB to power, we take a USB to power jack adapter. They are cheap cables, they're about £1 a piece. And obviously this is not limited to the 500 milliamp per, so we don't really care. It just means you have one socket on the front. I would have loved to have given you a whole selection of sockets. As it stands,
It's a bit tight.
That's too big.
Power buttons and
Actually, I can probably
because
space stuff so I can actually plug cables in and out of it without actually needing a pair of tweezers. I could probably shave off 15mm per EUT by really bringing the connectors close together. It's still not going to give me enough space, so I'm going to have to refactor the front panel. I'll probably end up losing the individual 3.5mm plugs and ending up with a multi-way connector for your GPIO. I don't like that because I'd like to have individual cables for each EUT. I'll see if I can do something better.
I think it'll be interesting to get feedback on how much the GPIO feature is even used.
Exactly,
Yeah.
but you got tons of boards, Jetson
Yeah.
TK1,
Yeah.
I mean, you have to have that. In fact, I'm using an IFC 6410 with the expansion connector to drive a GPIO. So I've got to have 2 boards to just test 1 board, and it's
Yeah.
terrible.
I'm not sure. I'm kind of thinking maybe if I have to go to a multi-way connector, I'll try and put more GPIO available. At the moment, you've got 8 lines.
So the other thing
Maybe we
to
should make it 16.
GPIO line for is testing bootloaders. Like if you've
Yeah.
got, if you could close a circuit to make it boot off of the EMMC bootloader
boot-
to flash
change the
on
media.
the
Yeah.
SD
Hold the boot config line down
Exactly.
at boot time.
Suddenly you gain the ability to actually test bootloaders properly because you're just using different media on the board.
So are you planning to incorporate like SD-MUX switching capabilities? So
That's on the EUT side. You'd actually need cables connecting into the device to provide that the SD card. So that would actually be something you would fit to the device, but then comes into that.
No, I mean I was thinking in terms of the all LMP SD-MUX card. That allow you to flash the SD card.
That's stalled at the moment, Carlos. The LMP stuff. We're looking at a different solution, which probably will be a lot simpler to deploy and can actually be just on the.
Okay, so
But-
on this board there are no plans to support.
There's
that.
no SD on here to the outside world.
Okay. And do you have GPIO support per UT on this board?
GPIO is uncommitted, so there's 8 channels. It's pull down only, so it's not air gap isolation, so it's common ground. It's 12-volt tolerant, but it's not power out, so it's pulled out, as I said, pull down only. So if you've got units which require 3 GPIO lines, you've got 6 to play with, because you can run 2 EUTs without having to expand it at the moment. If you only need the 1, fine. If you don't need any, that's also fine.
So I've got 4 extra Rev C boards. I'll donate to this. When the first boards come out, I'll send you guys the legal fund blacks. Get started.
We've got some tests as well. We'll have to call it though. We were late starting sadly.
Where do
so-
people sign up?
Oh, where do people sign up? Yes. Drop us an email. Sorry, I'll get to the end. Yeah. If you either drop Neil or myself an email at this point in time, let us know you're interested and what we can do. And we'll take it
Any
from
further
there.
questions come to us? We did start late and we'll now run late as well.
Thanks, guys.
Thanks.
Thanks.